Okay, so we've talked about WebRTC and how it's got all this great peer-to-peer aspect to it. But what's coming next? And so in the short term, when we think about just the technical changes and implementation changes, WebRTC is not a fully complete or approved standard yet. It's very close to version 1, but it's not quite there yet. And certainly some things that are still changing, as have been mentioned before. Microsoft Edge support is coming. Everyone has speculated for a long time about Safari and iOS native support. And it seems, since Apple has posted jobs looking for WebRTC developers to join their core team, they don't share very much publicly, but the job postings are leading everyone to believe it's coming soon. Whatever soon is, who knows. But other more details, the VP9 codec coming out, which will reduce latency and improve quality of the calls for this and more efficient use of the data in the calls, as well as talking about adding an additional error handling on connection right now when the ICE connections. The ICE candidates fail and you can't establish a connection. There's not very much feedback given to you about why or what happened, and so there's talk about putting more of that into the standards. And if you're interested in these sorts of changes in the standards as they are happening, a great resource to check out is WebRTCstandards.info. They do blogs about it and a regular webinar series. It's very good. In terms of, I have a technical background, but I'm really more of a business person at this point, so I'm always thinking about how is this going to change business and what sort of apps are we going to be building for it for our clients and for ourselves. And certainly we see that there's going to be a lot of continued development of one-to-one video chat type of applications, but more being done in group calls and media servers for handling larger, not necessarily pure WebRTC connections, but larger WebRTC conversations is certainly a frequent request of how can that be built. More broadcasting, like the sports celebrity tool that was shown to you today. Broadcasting tools using WebRTC are pretty popular right now. And then thinking about what are the other things that you can do with it that are maybe more around the data side, or Internet of Things is very interesting to me, but there's not a whole lot happening there yet with combining video with the data from the Internet of Things. And considering also whether you build your WebRTC application from scratch, essentially, as Herman very bravely did for you on the screen earlier, or whether you go with a platform. So those are all important considerations to take into mind. But one really important thing that I want you to remember, and I like this quote from that Twilio conference that I was at a few weeks ago. Al Cook from Twilio said, look, WebRTC is really just a printer driver. This is really cool and fascinating to us as developers that we can do these things in the browser now so much easier, but ultimately it's a transport layer, it's a driver. It doesn't provide any value inherently by itself. It's all how do you use it within an application and what value does that add. We shouldn't just throw video chat on everything we do just because we can, right? It has to have some intrinsic value to the customers. So what we wanted to wrap up with is something that's not entirely WebRTC, but I think is intriguing to consider how video chat could be combined with other technologies that are very trendy right now. And anyone want to guess what I'm going to say is this like uber trendy topic right now? How about bots? Yeah. Right? Bots and artificial intelligence with Facebook's their developer conference and Google I/O conference. There was talk about more bots, automated bots, and human interaction. And so if you're a WebRTC developer, and a common use case of WebRTC is contact centers, call centers, that type of bringing human interaction into an application. We also have a lot of talk right now in our field about, well, how can we have more bot interaction? So what's going to happen? Are we setting up a cultural war between bots and humans here? Well, maybe not. Maybe not. So we want to just kind of walk through a quick little example and imagine how we could use this. Imagine that you have a doctor's appointment tomorrow, okay? You need to remember when is your appointment tomorrow, and you're probably going to call the doctor's office and do this. When is my appointment tomorrow? What do I need to bring with me? My prescriptions, any records with me? And maybe are they going to do like blood work? Do I need to skip breakfast? Or I really like breakfast, so this is an important question to me when I go to the doctor. Can I eat before I go or not? So I'm going to call and ask them that. So how could we do that with a bot and a human together, maybe? So I might call, or maybe I'm going to text. Maybe I'm going to use Twilio's SMS API, and I'm going to text something to my doctor's office. And the bot sees the message come in for me, and it can automatically do some things and give me some information. But there's a certain point where maybe I've exceeded the intelligence of the bot, and so it needs to pass me off to a human, and that's where WebRTC comes back in. So this is probably not the most elegant looking architecture diagram I've ever drawn, but just to give you an idea of all the different technologies that might go into combining artificial intelligence and WebRTC together. On the patient side, we might contact the office through a regular phone call over the telephony network, or maybe through a video chat through the website, or SMS text messaging, or just a regular text chat on the website itself, right? We need to take that information and get it to a bot, which means we need to build in some APIs for speech to text or text to speech translation. We need a tool for natural language understanding to understand what's been said, right? So we potentially have some WebRTC going on here on the left-hand side, but then we're going to take that voice of me talking into the video chat, put it in to an NLU, send it to some artificial intelligence, which is going to figure out what I'm saying, and then give that to our actual application logic. So there's a whole lot of things going on here that aren't custom applications we're building. There are other tools we're integrating. And then our app takes that condensed information from the AI and is able to actually look up what time is my appointment tomorrow and return that information back to the bot so that the bot can tell me. And if the bot needs to connect me to a real human, we could go back through WebRTC as well as one of these other channels for that. And so there's a lot of different tools that you might use in this that you could use on the phone or SMS or WebRTC side of, just on the phone or SMS side. You could use Twilio, you could use Voxphone, you could use Telestacks and others. On the natural language understanding and processing of that, we might use IBM Watson. You probably heard of that from the Jeopardy show when it beat the other Jeopardy champions through their artificial intelligence. It's now an API that you can use and tap into the artificial intelligence, not only to win Jeopardy, but to train it to answer whatever questions you need it to. And then there are other tools like VoiceBase and Clarify that also help you with natural language understanding and parsing out the text that is converted from that voice. And then, of course, on the WebRTC side, when we've got that part on either end of the conversation, we might look at TalkBox, Twilio, Xersys, or a number of others. So if, and a lot of this is built in. So in Chrome, Google has a browser here that was recognizing I don't trust myself for internet demos as much as Armand or Andrea do, so I pre-recorded everything. That'll make this go a little faster for you anyways. In this one, I'm speaking in Spanish. Trust me, my accent was awesome, and it recognized what I said in Spanish. And then I'm going to send it to the translation, and this is all basically done with WebRTC to capture my voice, take the Spanish, send it to the natural language, and then it takes my awesome Spanish and does a mediocre translation of it to English. That's not really, even I know, that's not a very good translation of that phrase to English. But nonetheless, with a smarter AI or API behind that, we could do better real-time translation of even my bad Spanish. And Some of that is just built into Chrome now and tools provided by Google. This particular demo here of the taking my voice and translating it is from a site called WebRTC-Experiment.com, which is a whole bunch of tutorials that I highly recommend. Anytime you're thinking, how would I do this with WebRTC, it's a great site to go check out, run by Muaz Khan, and he's just made a lot of great tutorials there. And then one last one. These bots this is going to be a little hard for you to read, but this is a demo from Bluemix from IBM of me ordering a pizza through their bot. And it's doing the natural language understanding part. So for example, the first phrase here is, I can help you order a pizza, what size would you like? And I said, the biggest you have, of course. And if you could read this, it's a little small, it's determined that it's going to give me an extra large pizza, because I said the biggest pizza you have, so it says extra large. So you can train the bot to understand what some of these things mean, and it goes on. So all of this is cool, but we want to build definitely very contextual and powerful bots. So I'm going to have David do a short demo for you here.
Yeah, a little bit of explanation of what's coming is we are building actually we have an internal project that, as you said when it was some time ago, it was an internal project until we graduated it into something that's better now. So we have something internal that we have just a week or two working it. So this is, what I'm going to show you is our application is Uni. Uni has two phases. It has the face to the patient and the face to the doctor. You can play, see. So as you can see, I'm going to start trying to explain what is happening here. If I miss something, Jorge, she's going to correct me. I'm probably going to ask because it's funny to hear you. To hear Jorge speaking Spanish and English. So what we're doing here is giving the context, giving the information to the bot that this is a health assistant thing. Very important is that we are giving a lot of rules here, but what we are doing is taking the English phrase, the sentence, and then we are using SyntaxNet from Google. I mean, do you remember that Google released the SyntaxNet library that is built on top of TensorFlow? And on top of that, they released Parse my Parseface, which is the actual model in English that has the ability to really understand, to give the structure and the meaning of the phrase in English. So what we do is that we take that phrase and we build like a tree structure that tells me what is the intent of the phrase, and we capture the important things that we are paying attention. We build pattern matchings. We do pattern matching of the part of the tree that is constructing this SyntaxNet output, so we can hook in the nodes the responses that we want to then use in here. So, so that's the interesting here is that we what you have seen here is that the bot needs to have the ability to give the sensation that he's thinking, writing the answer. He doesn't need that time, of course, but it is something that allows engagement with the people. Now, this I want to emphasize this, and Eric has said this many times. The reason that WebRTC is so successful right now is that enabled the real-time capabilities for everybody. So the real topic here is not necessarily WebRTC. The real topic is real-time. So if we can use WebRTC and we can pair it with something that helps the real-time urgency of all the niches that we can think of, now we are solving a real problem here. Now, if we go to the other view, which is the view of the doctor, what is going to happen here is that the doctor is going to learn about the appointment that happened with the new patient, and he's going to interact. Now, I have to say, there are like 2 or 3 artificial intelligence machines running here. The first one is the one that needs to convert from speech to text. That's one. The second is when you have to take that text and convert it into a tree structure that gives meaning of the sentence, so the programmer can do hooks to give answers back to the person. Now, the other part that is very important, and maybe Jorge can explain this better than me, is now that I understand what the patient is telling me, and I know the symptoms, the signs that he's complaining about, now what I have to do is go to the other artificial intelligence machine to ask, given these symptoms, what is the approximate disease or illness that the person has. Of course, we are not giving that responsibility or that decision-making process entirely to the artificial machine. What we are doing here is approximating something that the doctor can then use and refine later, so he can improve and he finally, ultimately give the prognosis of what is happening. Jorge, Jeremy's. Hey, Jorge's coming.
No. Actually, clinical diagnosis systems has been used for the last 30 years or more, but they weren't using artificial intelligence or neural networks at all. They were just a couple of steps that medicals or medical assistants or medical practitioners needed to follow in order to diagnose the most common illness of the moment. And WebRTC knows provide a new way to understand and implement these clinical diagnosis systems into better platforms and more faster and reliable ways to connect the patients with the practitioners. And I want to give you some feedback about how important it is to move forward with this kind of technology. Any of you know how many medics or doctors are in the world right now? No? Okay. There is an estimate based on the World Health Organization that we have around 59 million medical practitioners in the world, not just the doctors, but the nurses and the surgeon helpers and everyone related with the medicine. And to understand the small this number is, we have 7 million persons in the world, and at least the 80% of these practitioners are located on the most developed countries. To understand the numbers, we have 46 medics here in Argentina for each patient. We have around 2,000 in the United States. You are 300 million persons. But in the underdeveloped countries of Africa, they have one doctor for each 50,000 patients. So this kind of technology allows the practitioners on any part of the world to diagnose and even treat patients that are located far away from them. And just as an example on how important is this, the World Health Organization needed 6 months to send the first team to Africa to stop the Ebola epidemic that was starting there when they first noticed the symptoms. They didn't have a single doctor in 500 kilometers away, but they all have smartphones when this disease come up. So if they had access to this technology, and if the neural network that is behind this platform was able to detect the symptoms and the conjunction of problems that I met to the Ebola disease, the response had been faster, and the epidemic will be slower or will expand slower, or even it wouldn't expand at all, because the health organizations will be able to send faster response to the places that they are having. So.
Thank you. Now, this is important before I come over the microphone. What Erin is going to show you is something that we didn't have the time to do at uni, which is the actual integration with WebRTC. But something that Jorge mentioned, we actually had, I have careful, right? I have to be careful with what I say. So we actually have conversations, right, with people, I mean, with potential clients in Africa, addressing this exactly concern. But because we want to be responsible, everybody wants to be responsible in the sense that we actually need someone in the field that can help to translate what is happening to the person that is sick to the doctor that is located in the States, for example. So yeah, I mean, those conversations are actually happening between us, with us and the clients. So this is important.
So just a quick example then of kind of the last step of that process is I took a bot kit, which is an open library that you can use for building a bot that responds to messages. It doesn't have full artificial intelligence behind it at this point, but it will, you can't read the text on the projector, but basically I'm saying, tell me more about the appointment tomorrow. And it's already told me my appointment is at 9 a.m., but I've kind of stumped the bot now. I'm asking it questions that it doesn't know how to answer. And so I say, can you please connect me to a human? And that's kind of a keyword that I built into the bot. And so it says, absolutely, one moment please while I call the doctor for you. And it established, so the bot has initiated the WebRTC call for me using Twilio video. And so that's kind of the final step of that process. And the code to do that is pretty simple in using an API. On top of the WebRTC, you'll see this is simpler than what Armand was showing, though obviously you have less control over it, but basically you create conversations, clients, and you invite people to them and attach that media to a display, to a video tag in your application. And this code is basically sample code from Twilio. And we'll post the links to this in the meetup group so that you see that. And there it is. Those are the links, but don't feel like you have to write that down. We'll put that in the meetup group, as well as over the next couple of weeks, we'll put some videos and slides from these presentations up there as well. So I want to just wrap up and say, I hope that you got some inspiration here for what you can build. There's all sorts of different fields WebRTC will apply to. Thanks again to everyone who spoke, and thanks again to our sponsors, and thanks for coming.